Alright guys, so this is where we left off on Friday in class. So let's kind of go from here. We were on problem number 6. This had the variables on both sides. We had talked through, okay, our first step is to still get the absolute value by itself. We had done that. Now that we were here, we still had to set up two cases, the positive and the negative version of this absolute value. Alright, so at this point, we are ready to solve these. So, the one on the left, I'm going to subtract the 6x from both sides. And divide. So there is one of my solutions. My other one, the one on the right, again, I'm going to subtract the 6x. And divide. It's okay that we have fractions. I'm going to call this a positive 1/5, or if you call it 0.2, that's fine. Now, I mentioned this in class, and this is very important. When we have the variables on both sides, it's imperative that we check our answers to the original problem, because sometimes we'll plug this back in the original problem and everything will work out, but sometimes it doesn't. So I need to go back up to where my original was. And actually, if I wanted to, I could go to where the absolute value is by itself, but just to play it safe, I'm going to go to the original. So if my two possible answers were either 1 and 1/5, if I'm going to check them, if I check 1, that means I'm putting 1 in for the exit. So 8 times 1 gives me 8. So I'm checking the version where I got 1. Okay, 8 times 1 gives me 8, and then I add 2 times the absolute value. 6 times 1 is 6, minus 2 is 4. Absolute value of 4 is 4. So 2 times 4 gives me 8. This checks out. Versus my 1/5. So I need to check now my 1/5. Okay. On the left-hand side, 8 times 1/5 gives me 8/5. On the right, 2, and then the absolute value, 6 times 1/5 gives me 6/5. If I subtract 2 from that, 6/5 times 2 gives me, 6/5 minus 2. So I have 6/5 minus 2. Now I don't necessarily care if you work in decimals or if you work in fractions. I'm going to work in fractions. If I work in fractions, this one gives me a negative 4/5. If I take the absolute value of negative 4/5, I get a positive 4/5. And if I multiply that by 8, I actually get 8/5. So this one checks out too. Now, I understand that both of these checked out, so my solution set really is 1/5 and 1. Again, I understand they both check out here, but that's not always the case. Okay? So let's look at the next one. Here again, I need to isolate the absolute value or get it by itself. So the first thing I need to do is divide both sides by 3. I can do that even though there's a quantity on the right-hand side. So I'm left with absolute value of 2x plus 2 on the left, and 1x, or just x, plus 1. Now here again, if I have the absolute value on the left, I need to know when that quantity is x plus 1 units to the left and x plus 1 units to the right. So this is where I'm going to set up my two different cases. So either 2x plus 2 is equal to x plus 1, or 2x plus 2 is equal to. Now, we always talked about making the other side negative, thinking about the situation where it's coming from the left. That's still true, but if there's two pieces on the other side, I need to make both of them opposite. So I need this to be negative x minus 1. Both pieces need to become opposite. Now, as I mentioned in class, I am confident at this point that you can solve these, hopefully with little errors, and also hopefully very quickly. So the first one, I should get negative 1. The second one, I got positive 1. Now, it does not always happen that I get the same positive and negative version. We saw that, but every once in a while. Now, I need to check this work. Just because I got these answers, I'm not sure if they're right or not. So I have to go back up and I have to check them. So the one solution I got was when x is negative 1. If I plug that in, I have 3 times the quantity, 2 times negative 1 is negative 2, plus 2 is 0. And on the other side, I have negative 3 plus 3. Absolute value of 0 is 0, times 3 is 0. This side gives me 0. This one checks out. I also have to check my other answer, which was a positive 1. So if I check x is positive 1, plug it in, I get 3 times 2 times 1 is 1, or I'm sorry, 2 times 1 is 2, plus 2 is 4, and I get 3 times 1 is 3, plus 3. On this side, absolute value of 4 is 4 times 3 gives me 12. This side I get 6. This does not work. That's not true. I don't get the same thing on both sides. So in this case, that 1 was an extraneous solution, and my only answer is the negative 1. Okay, so as I mentioned, I said this in class, I'll say it again. When this happens, that positive 1 is what we call an extraneous solution. It's extra. So this is extraneous, and we will see this a lot throughout the year. This term just means it's an answer that I get that doesn't really work. It doesn't satisfy the conditions necessary. And I'll always call your attention to when we actually have to check for these. Okay, looking at number 8. What I want you to do is go ahead. The nice thing here is that absolute value is already by itself, so I'm at the point where I can consider my 2 cases. So either x plus 10 is equal to the quantity 4x minus 8, the version on the right-hand side, or x plus 10 is equal to 4x minus 8 spaces on the left. What that means is I need to make both of those pieces negative or opposite. So it's going to be negative 4x plus 8. Okay, so go ahead and pause the video here, try it, and then check your work with me. All right, so here's where we're at. Hopefully you ended up with the same 2 answers I did. Now, we need to check this. So I'm going to take both these answers and I need to see if they work. So if I'm going to check the x equals 6, and I don't care where you check them on your paper, if you check them at the bottom, I'm just trying to keep it so we can see the problem at the same time. So if I plug in absolute value, 6 plus 10 gives me 16 inside the absolute values. On the other side, 4 times 6 is 24, minus 8 is also 16. And on the left, the absolute value of 16 is 16. So this first one checks out. If I plug in the negative 2/5, so if I'm going to check, okay, when I plug in negative 2/5 on the left-hand side, negative 2/5 plus 10 is going to give me 9 3/5, or that's going to give me 48 over 5. So I'm looking at the absolute value of 48 over 5. On the right-hand side, 4 times negative 2/5 is negative 8/5. And if I subtract 8, that gives me negative 48 over 5. Even though these 2 things look very similar, they both have 48 over 5, you have to think about what this means. On the left-hand side, when I take the absolute value of positive 48 over 5, it's just 48 over 5, which is not equal to negative 48 over 5. So this solution does not work. Again, it's extraneous. So my only answer in this case that works is the positive 6. All right? Looking at number 9. Now, let me get you, again, started to a point with this, and then I want you to try it. So there's nothing I can do until I get absolute value by itself. So the first thing I want to do is add this x to both sides. And then I have that 2 in front. I need to take care of that also. Divide both sides by 2. Again, I'm at a point where now I'm ready to go to set up my 2 cases. Please remember, if nothing else, that you may not set up the 2 pieces for absolute value until you isolate it. So once again, pause the video, try it, and then we can check our work with one another. All right, so hopefully you ended up with these 2 answers. That's my hope. If you notice though, I said the only solution was 3. Here's why. I'm going to scroll back up. When I plugged my answers in, when I plugged 3 into check, it worked. When I plugged 1/3 into check, it did not. Now, someone in class asked me, is the negative case always going to not work? That's not true. I mean, if you look back to some of the other ones we did, if you look back, I think 5 and 6, both cases worked. Okay, so make sure you don't always assume that the negative case is going to work, because that's not always true. It's true frequently, but not always. All right, if you look at number 10, 10's a word problem, obviously. Just when it talks about central value and range, central value is a term for the norm, or what we're used to seeing. So central value is like saying what's normal, my norm. And range is my variance, meaning how things are going to vary. Like what's the specifications that I'm allowed to vary by. So when I look at this, an adult tennis racket has 100 square inch head plus or minus 20 square inches. My central value is 100. So this is my central value. That's my norm. Versus the 20, that's my variance. So when I go to plug this in and write this as an absolute value inequality, I'm going to have the x minus 100, because it's my central value, equals 20, because that's my variance. If I look at this absolute value equation, it's already by itself, so I'm at the place where I can set up my 2 cases. Either x minus 100 is equal to positive 20, or x minus 100 is equal to negative 20. Both of these should be a very quick and easy solve for us. Either x is 120 or x is 80. So even though that was a word problem, that was a nice, fairly simple one to end with. So what I need you to do, make sure you get all this down, reread this a couple times, and Monday in class we will spend time going through this and making sure it's okay.